Today, I bring a relatively difficult concept in relative motion. I am DATTA sir. I am a senior IIT JEE faculty. In my career, I have seen the students are struggling with various concepts. So, I have decided to make videos on these specific concepts so that they get benefited out of it. If you are one of them, then definitely you will be benefited. In that case, please like this video and share it as much as you can. Also, I will be making this type of videos and posting regularly so that if you like this channel, if you subscribe this channel and press the bell icon, you will get notification of new video whenever it is published. Also, I want you to make comment and inform me what other concepts you want videos. In that case, it will help me to bring new videos. So, I am going to the topic. Say, relative motion, particularly here we are talking of relative velocity. You know, practically speaking, any velocity is relative because it is relative to someone who is observing the velocity. Now, in the world, in the universe, everything is moving. So, we cannot get any observer who is at rest. But still, we make a working compromise. We take an observer who is at rest on the ground, means at rest on the earth. We take him as observer at rest, and any velocity with respect to him as observed by him, we take it as absolute velocity. So in that case, if two velocities are there, one is VA, that is the velocity of object, and one is VB, that is the velocity of the observer. Means here observer is not at rest. In that case, the velocity with respect to observer will be VAB, which is VA minus VB. Means this will be a vector subtraction, not scalar subtraction, because it will depend on the angles between them. They may not be in same angle. Now, in such cases, there are few situations arise. Suppose two points are there at P and at Q, and the observer is at P, he is moving with velocity VA or A, we can say, and the object is moving along B vector, and in between the distance is D, initial distance. Now, A may be moving with an angle alpha with the line joining two initial points, and B may be moving with angle beta with that line. Now what happens? In that case, this initial distance PQ may not be constant. They may either increase or decrease. If it increases, we say they are being separated. If it decreases, we can say they are approaching each other. But the velocities are not along that line. So what we do, if we take two components of the velocity, one along that line and along perpendicular to it another, then we get two components of A as VA cos alpha and VB cos alpha. VA cos alpha is the component of A along the line of joining, and VA sin alpha is the component perpendicular to the line of joining. Similarly, velocity of B, which is VB, it will have also two components. One is VB cos beta, another will be VB sin beta. Now VB cos beta and VA cos alpha, this will be along the line of joining. But the VA sin beta, alpha and VB sin beta will be perpendicular to the line of joining. They too have two different effects. The components which are along the line of joining, they will decide what is the velocity of approach or what is the velocity of separation. If VB cos beta is more than VA cos alpha, means the velocity along the line of B is more than velocity along the line of A. In that case, their distance increases. And if otherwise, means VB cos beta is less than VA cos alpha, then the distance decreases and they are then approaching. In the earlier case, they are separating. That is called relative velocity of approach or separation. That will be difference between these two components, means VB cos beta minus VA cos alpha is the relative velocity of approach or separation. If it is positive, then it will be separation. If it is negative, it will be approach. Now question is, what about the other component? Other component is perpendicular to the line of joining, both the components, and their relative velocity is VB sin beta minus VA sin alpha. Now, VB sin beta and VA sin alpha, that is the difference of these two perpendicular components. What does it mean? Means from an observer at P, the B will appear to move in a direction perpendicular to PQ. Now, if there is any velocity perpendicular to the line of joining, that means it behaves like a circular motion with radius PQ and center at P. So that definitely that circular motion has a velocity VB sin beta minus VA sin alpha, that is perpendicular to the line of joining, and the radius is PQ, means say D. Then V by R is always angular velocity of any circular motion. So here also VB sin beta minus VA sin alpha divided by D gives the relative angular velocity of Q with respect to P or of B with respect to A. That means here two effects are there. One is either approach or separation, another is a revolution about point P. These are all instantaneous things I am telling you. This is about that particular instant. Now these two concepts definitely you will understand. It is based on the basic concept of VAB equal to VA minus VB, but they have enough use in various problems. Some very, very difficult problems can be done very easily by this. I am giving you a problem. Suppose there is a triangle ABC and there are three particles at A, B and C. Now all the three have equal velocity V. A's velocity, but the condition is A's velocity is always towards B, B's velocity is always towards C and C's velocity is always towards A. That means after a while, very small time, when A will reach to A dash, B will reach to B dash, C will reach to C dash, then their respective positions will be A dash, B dash and C dash, and their respective velocities will be along A dash, B dash, B dash, C dash and C dash, A dash. Now this triangle, every moment there will be a new triangle formed, and this triangle will go on rotating like this, and it will become smaller and smaller and smaller, and ultimately the three particles will meet at O following some curved path, which is very complicated curved path. They will reach at O. Now if each of the side of the triangle becomes D, and if it is asked what is the time when the three particles will meet, this problem, if you can try, otherwise it will appear to be very, very tough, because here nobody's velocity has a particular direction. Everybody will follow another. A will follow B, B will follow C, C will follow A, and everybody is changing positions. So direction is continuously changing, and their trajectory is a complicated curve, and they will ultimately meet at the centroid. But by using the relative velocity of approach, we can very easily do it.